Hey guys, have your notes pulled up for 5-3 day 3. We're going to find some local mins and maxes, but we're going to do it using the second derivative test, not the first derivative test. So let me make sure you know which is which. You found mins and maxes using a first derivative, and here's what you would do. You would do your first derivative, you get your critical values, and then you would make a sign chart. And you'd say, okay, well my slope was increasing and it switched to decreasing. Hey, I had a local max there. Or you found that your slope was decreasing and it switched to increasing. Oh, I got a local min there. True. But let me have you think just in a slightly different way. Let's look for mins and maxes using a second derivative. So, we still have to go through our first derivative. We still have to get our critical values. So let's do that. Our first derivative is 3x squared minus 12. We still need to get our critical values, so check where it equals 0, check where it blows up. Those are my critical values. Critical values. I think we have like a peak or a valley there at those places. Don't do a sign chart. Do a second derivative. Now, here's something kind of cool. Our original was a cubic. Knowing the end behavior of a cubic, I'm guessing, I think we're going to have a max at -2. Don't you? Your leading coefficient is positive. You've got a cubic. I think we're going to have a max at -2. So picture that. If you have a max, isn't your function concave down? So let's look at what's happening with our second derivative at our critical values. When I plug in -2 to my second derivative, see, -2 was one of my critical values. When I sub in -2 to my second derivative, I get -12. My second derivative is negative right here. So f is concave down, which means f has a maximum here. Now, I haven't found what the value is. I just know where it happens. Okay? And just I think I know what's going to happen on the next one, but go ahead and show it anyway. Plug in your next critical value, and that would be +2. And you get +12. So f is concave up. Since my second derivative is positive, f is concave up at 2. So f has a minimum, right? Minimum at x equals 2. And now you're supposed to find out what are they actually? So f of negative 2 turns out to be 11. And we said that's a max. And f of 2 is negative 21, and we said that's a min. Turns out we already did that problem, and we did that problem using the first derivative test. We got the same answer, but on the first derivative test, we said, hey, slopes were positive, slopes were negative. There's a max there. Slopes were negative, slopes were positive. There's a min there. Valid test. But to also get you comfortable with concavity, I had to do a second derivative test. So we found our critical values, no sign chart. We found our critical values, and then we said, at each critical value, what's my concavity? All right. Now, on the back, I have this already done. You're free to pause the video and copy it, or just maybe go through and do it on your own and then double check and see how you're doing, or maybe just watch. So I am given a position function, and doggone it, I hate it when they call the position function x. I really want it to be s. Whatever. So I got a position function named x, and it said find velocity, acceleration, describe the motion. Well, the first part's totally easy. Here's position, here's velocity, here's acceleration. Position, velocity, I also kind of called it v of t, and acceleration a of t. Okay, those were easy. And then it says describe the motion of the particle. So for motion of the particle, here's kind of what I expect from you. When was it moving right and left and stopped? When was it slowing down? When was it speeding up? And where was it during those times? Okay? So left, right, stop, that's a velocity thing right there. That's 100% velocity. Slowing down and speeding up is not 100% acceleration. It's a combination of acceleration and velocity. Slowing down and speeding up is not 100% acceleration. You've got to compare acceleration and velocity. And then where was it? That is 100% position. So, as far as left, right, and stopped, I set my velocity function equal to 0, factored it, solved it. I got 1 and 11 thirds. And then I came over here and I went ahead and made a sign chart for velocity. I put 1 there, I put 11 thirds here, I labeled it. My sign chart, I'm looking at velocity. I subbed in 0, positive, I subbed in, I don't know what I subbed in, maybe 2, and I subbed in like 10-ish or something. So, here we go, right, left, right. Stopped, stopped. Easy. Acceleration. Took my acceleration function, set it equal to 0, factored, solved it, I got 7 thirds. This time is when my acceleration was 0. So I came over here and I put 7 thirds in a sign chart. I labeled it acceleration. Subbed in some numbers. Okay, when t is 0, my acceleration is negative. When t is 10, my acceleration is positive. That in itself does not tell me when it was slowing down and speeding up. I need to compare that with my velocity. So typically the way I do it, notice how I kind of stacked my velocity sign chart and my acceleration sign chart, and I I lined them up. So 1 is here, 2-ish is here, 3-ish is here, right? And then what I typically do is I kind of like divide it on each of these numbers. So I will grab like a light, let me make sure you can see it. I'll grab like a light colored whatever. So I had 3 numbers in my sign chart. I had 1, 11/3, and 7/3. And at each location, I drew a vertical line. Remember, slowing down and, hang on, remember, right, left, right, easy. Slowing down and speeding up, you need to compare them. So here's what I can say. I can say from 0 to 1 second, it was moving to the right. So remember in your classes, Cole and, let's see, Cole was the one that I pushed out the door, and I think it was maybe Sky in period 7 that I pushed out the door. So remember how those two showed us positive and negative velocity. So these guys walked right, they walked left, they walked right. As he was walking right, I was pulling him in the negative direction. I was slowing him down. So moving right, slowing down. Up to 1. What happened at 1? Stopped. Okay, let's look beyond 1. Let's look beyond this vertical line. From 1 to the next vertical line. So from 1 to the next vertical line, he was moving to the left. And what was I doing? Pushing him left. So from 1 to whatever this number is, oh, that's 7/3. Moving left, speeding up. From this vertical line to this vertical line, so from 7/3 to 11/3, still moving left, but what was I doing? I was pulling the other way, slowing him down. So moving left, slowing down, up to 11/3. What happened after 11/3? Moving right, pushing right, speeding up. So, summary. Whew, a lot of writing. I'll go through it quickly. Hey, where did everything start? Where was he, or the particle or whatever, where was he when everything began? Well, I plugged in 0 to my position function. At time 0, the initial position was -5. The particle began at a position of -5. And then it did what I just said it was doing. Moving right and slowing down. Open interval, okay? Don't tell me it was moving right at 1, because you've already told me it was stopped at 1. Don't contradict yourself. Okay? Stopped at 1. Where was it? Oh, I figured it out. I plugged 1 into the position function and I got 5. So when it stopped, here's where it was. Then what? It was moving left and speeding up. And then it was moving left and slowing down. So still moving left. Stopped at this time. And it was yucky, but I plugged it in, and I totally used my calculator, and that's what I got. And then from 11/3 to infinity, it was moving right and speeding up. Okay? Hope that cleared things up. Hope that made sense. Good luck.